Good morning, everyone. I'm Roshni. Today I'll be discussing a fascinating concept in the field of cryptography and information security, that is, steganography. The word comes from the Greek language steganos, means hidden, and graphene means writing. Steganography is about hiding secret messages inside ordinary files like images, audio, or even text so that nobody even knows a message exists. It's different from encryption, where the message is scrambled but visible. In steganography, the message is invisible. Now, let's compare it to encryption. In encryption, we scramble the data so only someone with the right key can read it, but everyone can see that encrypted data exists. Steganography, on the other hand, doesn't alter the visible meaning of the cover file. A picture is still a picture. A song is still a song. This means an attacker may not even realize a secret message is hidden. Sometimes both methods are combined. First encrypt the message and then hide it inside an image. That gives two layers of security. Steganography is not new. It has existed for thousands of years. In ancient Greece, messages were written on wooden tablets and then covered with wax to hide them. During World War II, spies used invisible ink to send secret information. In the digital era, we use computers to hide data inside images, videos, and audio files. So, the techniques evolved, but the principle stayed the same: hiding messages in plain sight. Before we dive deeper, let me ask you something. How many of you have ever shared a meme or a funny picture online? Almost all of us, right? Now imagine, what if inside that meme there was a hidden secret message? Would you ever know? That's exactly how steganography works in real life. Hackers often hide their commands inside memes or cat pictures posted on social media. Security researchers have actually caught malware doing this. Let's understand the digital version. Most digital files like images, audio, or video have lots of redundant data. Steganography modifies tiny parts of this data to store hidden information. For example, in images, we can alter the least significant bits of pixel values. To the human eye, the image looks identical, but those tiny changes store secret data. Similarly, in audio files, we can hide data in inaudible frequencies. The goal is to hide information without changing the file in a noticeable way. Let me give you an example. This image shows how steganography hides secret information inside normal images using a technique called least significant bit substitution. The idea is that we slightly change the color values of the pixels in a way that it is not visible to the human eye but can carry hidden data. On the left, we have a normal image of two kids playing at the beach. Every image is made of pixels. Every image is made of pixels, and each pixel is made up of three color values: red, green, and blue. Each of these colors is stored in binary numbers. Here you can see the binary values of one pixel: red 100140, green 1000111, blue 0101110001. This is the original pixel before hiding any secret message. Now suppose I want to hide a secret message represented as the binary string 101001. 101001. To do this, I will take the last bit of each color value, called the least significant bit, and replace it with the secret bits. So after embedding the hidden bits, the new pixel value becomes red equal to 10010001. The last bit is changed here. For green, 100011100. Last bit has changed. For blue, 01010001 unchanged. The important thing is these changes are so small that the human eye cannot notice any difference in the image. But if someone knows the hiding methods, they can extract those least significant bits and recover the secret message. Steganography can be applied in several mediums: image steganography, audio steganography, video steganography, text steganography, network steganography. Image steganography means hiding messages in image pixels. Audio steganography is hiding messages in sound waves. Video steganography is combining both image and audio methods in video files. Text steganography is hiding data in formatting, spacing, or invisible characters. Network steganography is hiding data in network packets or unused fields of protocols. These different methods show how flexible the idea of steganography is. Let me give you a quick numeric demonstration. Imagine a pixel value of 110101110. If I change the last bit, it becomes 11010111. To your eye, the color is identical, but for me, I've just hidden a bit of secret information. Now imagine a 1000 cross 1000 image that's 1 million pixels, meaning I could hide roughly 1 million bits or about 125 kilobytes of hidden data in just one image. Let's do a quick thought experiment together. Suppose I have a normal 1080 pixels image. That's about 1920 by 1080 pixels. If I hide just 1 bit per pixel, that's over 2 million bits, which is around 250 kilobytes. That's enough to hide an entire text document or even a small secret program inside one single photo. So next time someone sends you a large photo, who knows, it could be carrying more than just a sunset view. Why use steganography? First, secrecy. Unlike encryption, it doesn't draw attention. An attacker may not even suspect a hidden message exists. Second, it can bypass filters or firewalls because the file looks like an ordinary image or song. Third, it can be combined with encryption or even stronger protection. And finally, it has useful applications in digital watermarking, copyright protection, and secure communication. Of course, it also has weaknesses. If someone suspects steganography is being used, they can analyze the file for unusual patterns. This process is called steganalysis. Another problem is file modification. If an image is compressed or resized, the hidden data may be destroyed. Also, the amount of secret data you can hide is limited. You can't store huge files secretly without making the cover suspicious. So while powerful, steganography is not foolproof. Here is another interesting point. Steganography isn't always invisible to computers. There are tools that look for statistical difference in images, tiny irregularities in pixel values that humans can't see. For example, if I send 10 innocent images and one steganography image, advanced software might flag that one picture as suspicious because the pixel patterns are slightly off. So, while steganography is great for hiding information, it's never 100% foolproof. Let's look at how it's used in the real world. Digital watermarking. Companies embed invisible watermarks in images and videos to prove ownership. Military and intelligence. Secret communication in hostile regions. Secure sharing of medical records and financial data. Even malware authors use steganography to hide malicious code inside innocent looking files. This shows how steganography can be used for both good and bad purposes. The future of steganography is evolving with artificial intelligence. AI can help create more advanced hiding methods that are harder to detect. At the same time, AI is also being used for steganalysis to detect hidden data more effectively. We may also see blockchain and decentralized storage being used for hidden data authentication. So, steganography will continue to play an important role in cybersecurity. To summarize, steganography is the art of hiding information inside ordinary files. It is different from encryption because the goal is not to scramble the data but to hide its very existence. It has many applications from copyright protection to secret communication. But it also has weaknesses, limited storage, risk of detection, and vulnerability to file changes. The best use is when it's combined with encryption. So overall, steganography is a double-edged sword. It can protect journalists, whistleblowers, and sensitive data, but it can also be used by criminals to hide malicious code. That's why learning about it is important, not just to use it, but to understand how to defend against it. Because in cybersecurity, the first step to protecting yourself is to understand the tricks attackers might use. Creating a powerful two-layer security system. That brings us to the end of the lecture on steganography. I hope this session helped you understand how data can be hidden in plain sight, why it is useful, and what risks it carries. Thank you for listening, and I would be happy to answer any questions you might have in the comment box below. Do like, share, and subscribe to my YouTube channel. Thank you so much.